Hey there, thanks for watching this video here about solutions for the little vector and polar coordinates test practice page. Our first problems are with vectors, so we're finding the magnitude of a vector right there. V is 3i minus 7j, so these are the horizontal and vertical components, and all we do is use those in the Pythagorean theorem to find the magnitude. Pretty easy. 3 squared and 7 squared make 58. So the magnitude of V, that's what those absolute value bars mean there, the magnitude of V is equal to the square root of 58. Easy. Finding the direction of this other vector u here, a little bit more involved. Vector u would look like this if you sketched it out. It goes 1 unit to the left and 4 units up. It's in quadrant 2. So we can find the direction of that vector by using the inverse tangent function of the y number over the x number, the j number over the I number, if you want to think of it that way. But that's basically vertical over horizontal there, and that's -4. Your calculator will say that that angle is -76 degrees. All right, when you take your inverse tangent on your calculator, you get basically -76 degrees. But that's not the right angle. -76 degrees would be down here in quadrant 4, but our vector is in quadrant 2. It's 180 degrees away from that, in fact. You get the exact opposite direction from the calculator. So you have to add 180 degrees to that calculator answer to get the true direction of that vector. Now, it's 180 degrees if your vector is in quadrant 2 or in quadrant 3. Here's a little scheme to remember this by. If your vector is in quadrant 1, just use the inverse tangent function to get the angle, no problem. But if your vector is in quadrant 2 or 3, you'll use the inverse tangent function, but then you have to add 180 degrees. And if the vector is in quadrant 4, well, you use the inverse tangent function, again, the vertical over horizontal like that, but then you have to add 360 degrees. So, finding the angle, a little bit of a problem sometimes. Not too bad though. All right, let's move on to the next problem. Find the magnitude of V plus 2 times U. Well, V plus 2 times U would be just those components worked out. 2 times U, here's vector U, that would be -2i plus 8j. And so when I add -2i and positive 3i, I get 1i, and -7j plus 8j is 1j. So it's just i plus j. That looks like this if you were to plot it out, 1 unit over and 1 unit up. The magnitude there is the square root of 2. That's a 45-45 right triangle with legs 1 unit long each. So square root of 2 is the magnitude. Now let's find the angle between u and v. Well, the angle formula for the angle between two vectors looks like this. If theta is the angle between two vectors, u and v, the cosine of that angle is the dot product, u dot v, divided by the product of the magnitudes of each of those vectors. So let's work that out. We got, let's see, here we go. U dot v, 3 times -1, that's 3 times -1, plus -7 times 4, -7 times 4, that's -3, and -28 is -31. So u dot v is -31. That goes on the top of the fraction. The magnitude of v we already found is square root of 58, and the magnitude of u is the square root of 17. You can look at that picture right there, hopefully go 1 squared, 4 squared, that makes 17. Square root of 17, when you work this fraction out, you get this -0.987, and then so that's the cosine of that angle is this number here. When you take the inverse cosine of that number, you get 171 degrees, pretty close to that anyway. So that's our angle between u and v. You don't have to worry about this next part, so I'm going to skip it for time's sake. Number 2, though, giving you 2 points and their coordinates, find the vector between them in ij form. All right, so we're starting with A and going to B. That means it goes over to the right. And if you just figure out what that distance is between the x coordinates, it's 18. And the distance between the y coordinates is 12. So it goes over to the right, 18, and up 12. So therefore, vector AB is 18i plus 12j. End of story. The last problem on this page is one that I'm not going to do, so I'm going to skip it. But I'm going to have one pretty similar to the next problem there about the plane going through the sky. So here's an airplane on a course with a standard compass bearing of north 30 degrees east. Okay, this is what that looks like. there's due north, and you go to the right, that is bearing eastwards, 30 degrees. So that's not such a great diagram, but it's more or less something like that. And it's flying at 200 miles an hour. So that's its magnitude right there, is 200 miles an hour at this direction. So that vector looks something kind of like this. However, a 40 mile per hour wind is blowing due south, altering the plane's course. That wind would be blowing due south like that with a magnitude of 40. So the true plane's direction and speed are more represented by this vector right here, which is a little bit shorter and a little bit more towards the east, blown off by the wind. So what we're going to do is write each of those two vectors, the plane and the wind, as component vectors. And 30 degrees means that this is part of a 30, 60, 90 right triangle. This measurement right there, that's half of the hypotenuse, so that would be 100, that's the horizontal, and the vertical is then this number times root 3. So our vector for the plane is 100i plus 100 root 3 times j. All right, so 30, 60, 90 right triangles coming to the rescue one more time. Vector for the wind, however, is due south. That's a 0 horizontal component and a negative 40 vertical component. So that's 0i minus 40j. When you add those two vectors together, you get 100i plus 133j, because 100 times the square root of 3 is about 173. So minus 40 gives you 133. And that is that's the horizontal and vertical components of our new resultant vector for the true direction and speed of the plane. And to write that like this, here is our vector for the plane, and then just to find the plane's true direction would be just true speed would be the magnitude of that vector then, and using the Pythagorean theorem there with those numbers gives you 166 miles per hour. My vector is in quadrant 1, so I can take the inverse tangent of the vertical over the horizontal there. That gives me about 53 degrees. One little wrinkle here, though, is that 53 degrees, that's this angle right here between the horizontal and the vector itself. The bearing for this plane would be expressed as degrees east of true north. And that is going to be, so 90 minus 53 is 37 degrees. So it's actually, the direction of the plane is this right here. North 37 degrees east. All right, so that's enough about the vectors and stuff. We're going to look at the polar coordinates now. And our page starts off with just kind of the basics of the coordinate system. All right, select all the r theta pairs that are equivalent to 5, 3 pi over 4. So that point looks like this over here in quadrant 2. So we need to have a point that's in quadrant 2 with a magnitude of 5 there, or that is a radius of 5. Now we're talking polar coordinates. It's the same math pretty much. Anyway, so -5, -3 pi over 4, that's Q1. That's not the right place. This is in Q2 though, in quadrant 2. So that point works. This point right here works, and this point right here works. All of these are in quadrant 2. And they are in the same location as the point that was given to us. Here's the point -1 pi over 6. So the radius is negative. It's in the opposite direction of our angle. So that point would be located right about there. Here we're going to find the polar coordinates of these 2 points right here. And so this first one, -10, 10 root 3, that's up there in quadrant 2 again. Our angle is 2 pi thirds from the unit circle. All right, use the unit circle, folks. And our radius then is 20 because that's 2 times the short leg, which is 10. So r is 20, angle is 2 pi thirds. This one down here is in quadrant 4, and these are odd looking numbers maybe to you, but the important thing is that they are the same. It goes over 3 root 8 and it goes down 3 root 8. That's a 45-45 right triangle. To find the hypotenuse, you just multiply the legs times the square root of 2. So 3 root 8 times root 2 works out to be equaling 12. So that's our radius and our angle right there, 45 degrees. That's 7 pi over 4. So there's our coordinates for that point. Okay, moving in the other direction here, these are maybe a little bit easier because all you have to do is take your r value times the cosine of the angle to get the x coordinate, and the r value times the sine of the angle to get the y coordinate. So you work that out for these problems here. I'll let you read through those. You end up with -4, -4 root 3. That's your x and y values for that polar number. And in quadrant 1, the second one, it's 1, that's r, times the cosine of pi over 4. And, you know, sine and cosine of pi over 4 are the same number. It's root 2 over 2. So our coordinates are root 2 over 2, root 2 over 2. Okay, we're almost done. This next one here, giving you a couple of complex numbers. This is a plus bi form, rectangular form, and your job is to convert each one of these into polar form. Well, it's pretty much the same math, folks. You just have to express the answer in a little bit different way. So our radius here is this number squared plus that number squared. That's 6 root 2 over 6 and up 6. Again, isosceles right triangle, hypotenuse is the leg times root 2. And our angle is 45 degrees, therefore the number looks like that. 6 root 2 times cosine 45 plus I sine 45. The next one is negative 2 root 3, negative 2. So again, down in quadrant 3, again, a 30, 60, 90 right triangle. Again, the radius is 2 times as long as the shortest leg. So that gives us a radius of 4. Our angle is 30 degrees below the x-axis there. That's 180 plus 30 is 210 degrees. So there's our number for the next one, okay? All right, moving on. This one, we're going to find the product of these two numbers. And if you remember, finding the product of two numbers in polar form is simply a matter of multiplying the two moduli together. So that's 24 root 2. And then adding up the two arguments, or the angles. So that would be 255. So that's pretty easy, huh? Adding or multiplying two polar numbers. Let's flip it over. And here we're going to divide, which is kind of the inverse process right there. Just divide the two moduli. 16 divided by 8 is 2, and you subtract the angles. 120 minus 30 is 90. This problem also asks you to express this number in rectangular form. That's a plus bi form. Well, remember, a is r times the cosine of the angle, and b is r times the sine of the angle. Cosine of 90 is 0, so 2 times 0 is 0. Sine of 90 is 1, and 2 times 1 is 2. So this number in rectangular form is simply 2. All right, moving on. Now we're going to do a de Moivre's theorem, a little problem here, where I take a number and raise it to a power. There's my number in to the fifth power. First, I want to change that number into polar form. All right, so here we go, negative 1 this way, root 3 that way. Again, a 30, 60, 90 right triangle. Again, the radius is 2 times the short length, that's 2, and my angle is 2 pi over 3. I'm going to use degrees, 120 degrees. There's my number in polar form. That's what I'm raising to the fifth power, okay? I haven't done any powering yet. So if you remember de Moivre's theorem, it says that all you have to do to raise a number in to an exponent is raise the modulus to that exponent and multiply the angle times that exponent number. So 2 to the fifth is 32, that's easy, and theta being 120 times 5 is 600. That works out, when you boil it down to once around the circle, is 240 degrees. So my number is 32 times the cosine of 240 plus I sine 240. And since I'm supposed to put that into rectangular form, once again, I'll use A as our cosine theta, B as our sine theta, and multiplying those numbers out, I get negative 16 for A, negative 16 root 3 for B, and so my number finally, therefore, is this number, when I raise it to the fifth power, is equal to negative 16 minus 16 root 3 I. There's I hanging around. Okay, hope you enjoyed that. Bye-bye.